Welcome back to the deep dive. Today we're diving headfirst into a concept that is, well, truly universal, yet incredibly personal. Okay, let's unpack this. We're exploring the idea of laws, these fundamental principles that seem to govern everything. From the vastness of space down to our deepest thoughts and even how our communities work. Our listeners given us an amazing stack of sources today. It really weaves together insights from cutting-edge physics, ancient philosophy, personal growth stuff, and really practical, real-world challenges. It's a fascinating mix.
Yeah, it really is. What's fascinating here is just how many different ways the idea of a law pops up across these really diverse fields. It makes you ask, isn't it? What do we really mean when we talk about law? Are they absolute unchanging truths, or maybe more like evolving models, reflecting our current, limited understanding?
Exactly. And that's our mission for this deep dive. We're going to journey through these different takes on laws, look at how they interact, how they influence our understanding of the universe, and, well, our lives. We're aiming for a richer, maybe more nuanced perspective. So let's start big. The grandest scale, right? The fundamental laws shaping the physical universe and, crucially, how our understanding of them has changed.
Right. It's vital to grasp that even in science, these laws aren't etched in stone. One of our sources, from Reddit's Rask Science discussion, makes this point really clearly. Our understanding is always being refined. Think about Newton's physics. For centuries, people thought, okay, that's it, final word.
Yeah, the apple falls, gravity, done.
Exactly. But then scientists looked at Mercury's orbit, and it didn't quite fit. It wasn't quite right, according to Newton. So along comes Einstein with this completely different, much more accurate picture of gravity and spacetime. And boom, his theories explain Mercury's orbit perfectly. No need for some imaginary planet they were looking for.
Wow, okay.
But even Einstein's model wasn't static at first. He put in a cosmological constant because, like most people then, he thought the universe was unchanging, stable.
Ah,
But then Hubble observes the universe is actually expanding.
which must have been a shocker.
A huge one. And Einstein had to adapt his own law to fit this new observation. You couldn't deny it. So the big takeaway, the profound insight here, is that scientific laws aren't absolute truths handed down. They're dynamic models. They evolve as we learn more, as our tech gets better.
That's incredible that even gravity isn't just fixed. So what happens when we zoom right in, way down to the tiniest bits, the building blocks of matter? Here's where it gets really interesting. Zooming in on the tiniest components. How do laws work there?
Well, Arvin Ash's YouTube video gives us a great look into this really intricate world.
Yeah.
They've got two main families of matter particles, leptons and quarks, and they both have this fundamental property called spin. You can sort of picture it like a tiny top spinning. Now, depending on its spin relative to its motion, a particle can be right-handed or left-handed.
Handedness for a particle.
Yeah, sounds weird, right? But this handedness is actually super crucial for how particles interact. It's not just a label. Take the strong force, for example. It's incredibly powerful, holds quarks together inside protons and neutrons. It's mediated by 8 different kinds of gluons. They literally act like cosmic glue.
8 types. Wow.
And what's also fascinating is how the weak force and the electromagnetic force, which do interact with both left and right-handed particles, they actually came from a single electroweak force right at the beginning of the universe. They unified back then.
So they split off later.
Exactly, as the universe cooled. And then you have the Grand Poobah, the Higgs boson, predicted over 50 years ago, finally confirmed about a decade back. It's what gives mass to other fundamental particles. Without it, everything would just zip around at the speed of light. The insight, really, is just how deeply mathematical and, well, intricate these fundamental laws seem to be. They dictate how matter exists and interacts with these unbelievably specific rules.
From the infinitesimally small. Okay, let's pull back again. Way out. The largest scales. The cosmos itself. What laws are running the show out there, and what are the big mysteries?
Right, so our sources from Harvard and Smithsonian and Archive get into the really perplexing stuff, dark matter and dark energy. Dark matter, you see, plays this huge role in galaxy clusters. It often outweighs all the visible stuff, stars, gas, everything we see.
And we can't see it directly.
Nope, but we know it's there because it affects how galaxies move. Its gravity bends light from distant objects too, something called gravitational lensing. It acts like a huge, invisible magnifying glass.
Okay, so we infer it's there from its effects.
Exactly. And the numbers are just staggering. The universe is calculated to be about, what, 72.8% dark energy, 22.7% dark matter.
And the stuff we're made of? Stars, planets, us?
That's only about 4.5%, just a tiny fraction.
Wow. That's humbling.
It really is. And this dark energy, it seems to have appeared around 4.47 billion years ago. It's accelerating the expansion of the universe, making it fly apart faster and faster.
And we don't know what it is.
Not really. Or dark matter, for that matter. There are ideas, of course. There's even this proposed MOND force field, suggesting maybe a repulsive force between normal matter and dark matter, which challenges the standard view.
So the profound insight here, despite all our amazing physics, our grasp of cosmic laws is still massively incomplete. We're surrounded by these invisible forces dominating the universe, really pushing the limits of our current models.
These physical laws, whether tiny or huge, they definitely touch on some deep philosophical questions, don't they? I know Roger Penrose has some fascinating ideas about math itself and its connection to these laws.
Oh, absolutely. Penrose brings up this idea of a Platonic mathematical world. He suggests that mathematical forms like a perfect square, a perfect circle, they exist objectively. They're idealized forms out there somewhere, independent of us.
So math isn't just something we invented. It's something we discover. That's the Platonic view, yeah.
Yeah.
Equating mathematical objectivity with this idea that these forms just are. And mathematics deals with these incredible infinite structures too, like Dedekind cuts. It's a way to define real numbers, all the numbers on the number line, by sort of slicing up the rational numbers, the fractions. It's a huge conceptual leap.
Okay.
Then you get the magic of complex numbers. Numbers involving the square root of -1. They pop up everywhere in physics. Euler's formula, Fourier transforms, quantum mechanics. In things like twistor theory, these complex structures are even seen as more fundamental than points in space-time.
Wow.
And you have other theories like loop quantum gravity, suggesting space-time itself might be made of discrete bits like pixels, contrasting with string theory, which uses extra dimensions, these complex Galabiau spaces. So the core insight, the big question Penrose pushes us towards is mathematics the language the universe is written in? Are we discovering these intricate laws, or are we inventing the mathematical tools that just happen to describe them really well? It's a deep one.
It really is a question about the very fabric of reality. But let's bring it back down to Earth now. Transition from those cosmic laws to the equally complex, but maybe more malleable, laws governing life, society, and our own minds.
Right. So starting with biology, our Chat GPT source points out these innate social instincts we have. Things like empathy, cooperation, reciprocity. These aren't just human things either. They have deep evolutionary roots. You see similar behaviors in primates, birds, lots of animals. They help the group survive.
So we're kind of hardwired for certain social rules.
In a way, yeah. The insight is that our biology gives us a foundation, a predisposition towards behaviors that help us function as a group, enhancing our collective well-being.
Okay, let's unpack this. How do these biological instincts then turn into the unwritten rules we live by in society?
The Psychology Fanatic source explains social norms really well. These are the unspoken rules. We learn them mostly unconsciously, just by watching people, interacting, growing up in a culture.
Things you just pick up.
Exactly. And our brains are incredibly tuned into this. There's a part of the brain's reward system, the ventral striatum. It lights up when we fit in, when we get social approval. We feel good.
The likes part of the brain.
Sort of, yeah. And conversely, if you break a norm, regions linked to negative emotions can activate. Makes you feel bad, awkward, maybe ashamed. Our prefrontal cortex, the thinking part of the brain, is key here too. It helps us learn these rules and make decisions based on them.
So it's biological reinforcement for social behavior.
Right. The core insight is that these social laws are deeply ingrained, reinforced by our biology, often working below the surface, but powerfully shaping how we interact and whether we feel like we belong.
So if we have biological and social laws, does the mind itself operate by its own unique rules? Is there a law of thought?
That's a huge question in philosophy of mind. The source on psychology and philosophy of mind talks about functionalism. This view says mental states aren't defined by what they're made of like neurons, but by their function, what they do, their relationships to inputs, outputs, and other mental states.
Like software running on different hardware?
That's a common analogy, yeah. Especially for machine functionalism, which sees the mind like a computer program, a Turing machine. But this gets challenged by things like the Chinese room argument. Imagine someone in a room who doesn't know Chinese, but has a rule book to manipulate Chinese symbols perfectly. They can fool someone outside into thinking they understand Chinese.
But they don't really understand it.
Exactly. So, does simply manipulating symbols according to rules equal real understanding, real thought? Then there's the Turing test, originally an imitation game. If a computer can chat so convincingly that a human judge can't tell if it's human or machine, does it have a mind? It requires real flexibility, adaptability.
Which brings us right back to AI today.
It does, and it raises that key question. If a machine perfectly simulates thought, is it really thinking? Or are the laws of the mind something more than just computation?
That's a fascinating line, especially now. And it leads us straight into one of philosophy's biggest, oldest debates. Free will, do we actually have it?
Well, the Stanford Encyclopedia of Philosophy defines free will traditionally as this power to control your own choices, where your actions are up to you in two key ways. One, you could have chosen differently, the ability to do otherwise. And two, you are the source of the action, the agent, not something else compelling you.
And this is tied to morality, right? Being responsible for our actions.
Deeply tied, yes. The insight is that free will is traditionally seen as the foundation for agency, for moral responsibility, the idea that we author our choices.
But then you get the other side. The deterministic argument, like we see in the Reddit moral philosophy source, that paints a very different picture, doesn't it?
It really does.
Yeah.
Determinism basically says all our decisions are just the inevitable result of everything that came before, all prior events going back and back. So free will is an illusion. Our choices are just complex electrochemical reactions in the brain, the final domino falling in this incredibly long chain of cause and effect.
It feels bleak.
It can, yeah. Though, interestingly, some comments in that Reddit thread suggest maybe hybrid models. Maybe intelligent beings can have some novelty, some singularity of thought, a real choice, even if an outsider couldn't detect it breaking the causal chain. But the core insight of pure determinism is stark. It challenges the very idea of choice. It presents a universe where everything, including what you decide for lunch, is basically predetermined by the preceding laws of cause and effect.
Wow. Okay, that deterministic view is quite something. Is there any middle ground? Or is it all or nothing? You mentioned a sliding scale. Here's where it gets really interesting. A sliding scale of freedom.
Yes, the Orion philosophy source offers this more nuanced view. It argues that free will isn't just on or off. It's something that can actually increase with wisdom.
Wisdom. How so?
They define wisdom as the ability to see the world as it is, really understand it. So by becoming more aware of our subconscious beliefs, how our environment shapes us, our emotional triggers, by understanding those influences, we can limit their power over our decisions.
So we become less reactive, more intentional.
Exactly. Less hindered by these external or internal forces we weren't aware of. So in that sense, our freedom, our capacity for genuine choice increases. The insight here is that free will might not be a binary thing, but more like a capacity we can develop, a continuum we move along through self-awareness and understanding the laws internal and external that influence us.
So given all these layers, physical laws, social norms, maybe limits on free will, what does this all mean for our individual agency in a universe governed by so many laws?
Well, the Stanford Encyclopedia also touches on non-deterministic causation. With the advent of quantum physics, all its inherent uncertainty and probability, the possibility opened up for events that aren't strictly predetermined by what came before.
The quantum loophole.
Some philosophers, specifically event-causal libertarians, see it that way, yes. They suggest this might be a physical basis for free will. The idea is that an agent's reasons, their conscious deliberations, could non-deterministically cause an action. The outcome isn't guaranteed, but the agent's reasoning strongly influences the probability.
So our thoughts could tip the quantum scales, so to speak.
That's the hope for some, yeah.
Yeah.
It raises this crucial question. Does quantum mechanics actually provide a scientifically plausible escape hatch for genuine free will in an otherwise deterministic-looking universe? It's a huge debate.
We've covered a lot of ground in science and philosophy, these sort of rigorous, sometimes abstract laws. But humans have other ways of trying to understand universal principles, right? Frameworks that mix personal growth, spirituality. How do those fit in?
Definitely. The Toon Explainer YouTube channel, for example, lays out some laws of the universe, but they're framed very much for self-improvement, like the law of cause and effect. Pretty straightforward. Your actions lead to outcomes, so take responsibility. It emphasizes accountability.
Makes sense.
Then there's the law of compensation. You get back rewards, money, happiness, whatever, based on the effort and value you put out there. And the law of inspired action. Just thinking or wishing isn't enough. You have to actually do something, take deliberate steps to make things happen.
So these are more like guiding principles for living.
Exactly. The insight is that these laws are prescriptive. They're guides for personal development, emphasizing responsibility, contribution, and action, within a framework of universal principles.
And then there's another set, the laws of love, which seem to take a more spiritual angle.
Yes, Paul Farini's work, The Laws of Love, presents these as spiritual principles for living harmoniously. He talks about inner authority, finding truth, finding God within yourself, rather than relying on external figures or institutions.
Trusting your inner compass.
Precisely. And the law of reflection. Our relationships act like mirrors, showing us our own inner pain, our conflicts, their opportunities to learn, not just blame others. Then the law of surrender, constantly letting go of a lesser experience for a greater one as your consciousness grows. It's about evolution expansion.
Interesting.
The core insight here is that these laws offer a framework for living in harmony, based on inner wisdom, seeing connections everywhere, and embracing spiritual growth as a continuous journey of discovery.
Now, for something that really stretches the definition of laws, we have a source, blending spiritual ideas with some, well, pretty unconventional cosmic stories.
Right. The Happy Science San Francisco YouTube source presents some quite unique perspectives. Just to be clear, we're relaying the viewpoints from the source here, not endorsing them.
Understood.
So this source discusses things like the spirit world and reincarnation, framing it as a Buddhist philosophy where souls are reborn repeatedly to learn and grow. It mentions forgetting past lives as a deliberate rule on Earth, designed as a challenge to make us strive to remember our true spirit self.
Okay.
It even talks about a galactic federation monitoring Earth, hoping humanity will enter a new era, uniting science and spirituality. But apparently there's opposition from reptilians.
Reptilians.
Right, yeah. So it's a very distinct, highly narrative-driven take on universal laws, cosmic purpose, and humanity's place in it all. The insight, perhaps, is how laws can also be understood through these kinds of mythologies and spiritual narratives, which offer explanations for existence and destiny that go far beyond typical science or philosophy.
Okay, from those very broad, sometimes cosmic perspectives, let's pivot now. Let's focus on the tangible impact, the real-world consequences when laws, biological, economic, systemic breakdown are challenged in our daily lives. There are some serious challenges here.
Absolutely. Srivatsa's autobiography really drives home the urgent threat of superbugs, antibiotic-resistant bacteria. The source describes it starkly as a potential global holocaust because, for some infections, there's simply no medicine or vaccine left that works.
That's terrifying.
It is. The WHO listed 12 priority bacteria back in 2017 needing new drugs. And one study found 9 different resistant strains just on London's transport network.
How does this resistance even happen?
Well, bacteria are masters of adaptation. They can share resistance genes directly with each other. Weaker bugs can essentially learn resistance from tougher ones. They also evolve ways to just bypass the antibiotics, pump them out, or change the target the antibiotic attacks. They can even multiply right in the presence of the drug.
And the drug pipeline is dry.
Largely, yes. The source points out no major new chemical class of antibiotics has hit the market since the mid-1980s. The pharmaceutical industry focus has shifted, arguably, towards drugs for chronic conditions, more profitable long-term treatments.
Plus, we misuse antibiotics, right? Taking them for viruses.
Exactly. Massive overuse, even when they won't help, like for colds or flu. That just gives bacteria more chances to encounter the drugs and develop resistance. The core insight here is stark. It shows how fundamental biological laws, evolution, adaptation, can overwhelm human-made laws of medicine when we're not careful, creating a potentially devastating global health crisis.
It really sounds like a slow-motion disaster. So what can be done? What are the solutions or preventative measures being proposed?
Srivatsa's work, and also this Designing Your Color-Coded System PDF, they offer some key directions. First, we absolutely need better control over using the antibiotics we do have. We need serious innovation to find new ones, and new strategies to combat resistance itself. Doctors play a crucial role in diagnosis, needing to be quicker, perhaps, but also avoiding just throwing antibiotics at everything without confirmation.
Reduce unnecessary prescriptions.
Right, and tackling wasteful consultations is part of it. The source mentions millions of health service visits for things like coughs or headaches that often don't need medical intervention, let alone antibiotics. That's where technology like the Dr Maya app comes in. It uses a color-coded system. The idea is to help people figure out if their symptoms are likely minor or serious, potentially guiding them to self-isolate if needed, offering basic advice.
So it empowers patients more.
Yes, and potentially connects them with healthcare providers more efficiently, especially during pandemics. The aim is to reduce health inequalities, cut down on wasted resources, and limit the spread of infections in clinics and hospitals. The insight is that tackling these huge, complex crises needs systemic solutions. It involves technology, policy changes, but also empowering individuals to understand and act responsibly within a public health framework.
Moving from public health to financial health, let's look at the global financial crisis. Another case where the laws of the system seem to spectacularly fail, right?
Oh, absolutely. The bank regulation and supervision source makes it clear the 2007-09 crisis exposed huge failures in market discipline, in regulation, in oversight, just massive shortcomings.
What are regulations supposed to do, ideally?
Well, the main goals are financial stability, preventing collapses, protecting consumers, and importantly, limiting excessive risk-taking by banks. Because one bank's failure can have huge knock-on effects, what they call systemic externalities.
So did regulations increase after the crisis?
Yes, significantly. Regulatory complexity went way up. Many countries adopted stricter global standards like Basel II and III, especially concerning how much capital banks need to hold against risky assets. But there was a flip side. Some argue that while complexity increased, banks found ways to shift towards assets considered lower risk by the rules, which might not have actually improved the quality of their capital buffers that much.
And then there's a moral hazard.
Exactly. That was a huge issue. Government safety nets, like deposit insurance, but also the big bailouts, they ended up protecting not just depositors, but sometimes shareholders and bondholders too. This weakened market discipline. If you think you'll get bailed out anyway, why not take huge risks?
Right. Heads I win, tails the taxpayer loses.
That's the essence of moral hazard, yeah. And you had these systemically important financial institutions, sci-fi's basically too big to fail. Their collapse would be catastrophic. This led to new ideas like bail-in debt, where a failing bank's own investors and creditors might have to absorb losses to prop it up, rather than just taxpayers.
And new threats keep emerging.
Always. Cybersecurity is a massive one now. The source notes that if senior management doesn't pay enough attention to IT security, critical systems can fail. Think ransomware, taking down a city's services. It's a huge financial and operational risk. So the profound insight from the financial crisis. These financial laws and regulations are absolutely vital, but their failures reveal deep patterns in human behavior, greed, herd mentality, loopholes. They show systemic vulnerabilities and the constant ongoing need to adapt and stay vigilant to keep complex global systems stable.
Wow. We have journeyed through such a vast landscape today, exploring just so many different interpretations of laws, from the subatomic to society, right down to the deeply personal. It's really been quite a ride.
It really has. And I think it's clear that laws, whatever field we're talking about, they aren't static things. They're dynamic. They're multifaceted frameworks, whether we mean the evolving theories of physics, those ingrained patterns of social behavior, the really deep philosophical questions about free will, or even spiritual principles guiding personal growth. They all shape our reality in countless, often really surprising ways.
And these ideas, they aren't just abstract, are they? They have real practical implications. We see it in the fight against superbugs, in trying to keep our financial system stable. So what does this all mean for you, our listener?
Well, maybe. If we connect all these threads, perhaps the most profound law isn't one we just passively observe. Maybe it's one we actively participate in creating. This continuous pursuit of understanding across all these different domains, science, society, self. Recognizing that our individual actions, our collective efforts, they continually redefine the laws of our shared reality and ultimately our place within it.
Something powerful to mull over until our next deep dive. What stands out to you, about the many different kinds of laws that shape our existence?